Today's focus will be talking about types of wind energy. So what actually makes up wind? So first off, what is wind? Wind is energy, because once again, we are always talking about energy in this class, and it's energy that's in motion. So once again, whenever you think of energy in motion, you should think of kinetic energy. So wind is a form of kinetic energy, okay, or it has kinetic energy in it. And what causes it is convection. Okay, so when we'll be talking about convection soon. Okay, so convection is the thing that causes the wind. Wind is the movement of air particles, basically. So what is convection? So convection occurs when you have high and low pressures. What you want to really note is that wind will always move from something that's high pressure to something that is low pressure. So how do you get something that's high with high pressure or low pressure? You change its temperature. So if you heat up a substance, what's going to happen with a gas? It's going to rise. Okay, you guys all know that hot air rises, right? That's why when you're in a fire, okay, it's the hot air goes to the top. If you're in an apartment building, it's hottest on the top floor as opposed to in the basement, right? So hot air will rise. And what happens is when it rises, it causes low pressure. And pressure is how many particles you have for a given amount of space, basically, is one way you can think of it as. You can also, for this sakes and purposes, we can say it's density. Okay, it's directly related to density. So when you have something that's hot, it spreads out, making these particles will spread out, making it less dense. Okay, then we've got cold. What happens when something is cold? Well, cold will cause these particles to move closer together, which causes a high pressure situation, which means that it is more dense or high density. What happens with that is that it will sink. So cold will sink, hot will rise. Okay, so let's draw a sketch of a basic flowchart diagram of this convection. All right, so basically we have the hot going to the cold. All right, so we need to label the areas of high and low pressures. All right, so high pressure, it always goes from high to low. Remember, high pressure means more dense. So which will be more dense, cold or hot? That will be something that is cold. So here's our cold. So this is going to be high pressure. And where is it going to go? It's going to go to a low pressure. What is low pressure? Once again, that would be less dense, which means that it is hot air. Okay, so we're going from high to low. All right, here's another visual of convection. So this one on the left is showing the difference in density. So when it is hot, if you look at these particles, okay, they are going to be spread out. We're assuming that they are the same amount of particles in the hot cylinder as in the cold. But what you notice is that when it gets hot, notice how much space these particles take up, whereas when they're cold, they condense towards each other and they make it more compact. So this would be more dense compared to when it's hot, it is less dense. Okay, so that's what this one is that they spread out when you get warmer. So this causes, when it spreads out, it creates more like openings. Do you see how there's more openings in this? Which means that these particles that are colder will want to rush into those little areas. So that's why it always goes from high, so this would be cold, to low, which would be hot. So we would go always from high to low, which would be in this direction. That's why it creates this. And this is the convection. So we would feel this as wind because the particles, the air particles would be moving during this time, and that's what we feel is the movement of these air particles. All right, so now you are going to absolutely need to know these global wind patterns, and these should be review for you. But what you need to know is that wind is always named by where they come from. So if it's a western wind, that means it came from the west. So it's going from the west to the east. Okay, you do need to know the names of these different guys. Okay, so we've got the doldrums. The doldrums are the global winds that are found on the equator. We have the trade winds. Okay, the trade winds are 30 degrees north and 30 degrees south of the equator. So if you're talking about 30 degrees, that's here. So anything within between that 30 degrees and that 0 and 30 degrees and that 0 would be known as a trade wind. And then the reason why they're actually called trade wind is they figured out that when you go from Europe, okay, which was where you would be trading originally to the Americas primarily, you would want to get down to the trade winds because they would push you faster if you went along this route to the United States than if you went along this route. If you went in the northern part, which is like right here, versus the southern part, which is right here, to get to the Americas, which is here, you would be always fighting the wind if you went this way versus this way. That's why they call it the trade winds, okay, because it was dealing with trading. Then we've got the prevailing westerlies, which is right here and here. Okay, once again, why is it called the westerlies? Because it's coming from the west. Okay, and then you have the polar easterlies, which are down here. Okay, you can't see it on the bottom part of this, but you can see it on the top part of the diagram. And what does that mean? That they came from the east, right? What I also want you guys to note is that the wind directions. How are you going to figure this out? Well, what do you know about the equator? The equator is extremely hot, right? So that is going to be hot compared to everywhere else, which means that what is it going to have as far as pressure goes? If it is hot, it is going to be a low pressure system, okay? Which means, and then they're going to alternate. So if the equator is low pressure, then the next one has to be comparatively high pressure, okay? And then we've got a high pressure, so the next one has to be a low pressure, right? So then you've got the next one, which is a high pressure, the very bottom at the poles. So if you notice, what does it always do? Wind always goes from high, or because of convection, always goes from high to low. And also because we've got a spin going on, it's going to do a little bit of a direction change. But if we were going here, we're going to go high to low. That's why it goes this way. We're going to go from high to low. It's not showing up very well, okay? So we will always be going now from high to low on the westerlies. So notice it's going to go this way because of turning. And then high to low. And then if you look at the easterlies, where we're going to go from high to low, that's why it goes this way. All right, if you look at this, this is an image of Jupiter. And so we've got this, and notice all of these different things. They show a very good job of this as far as the differences in convection. So we're going from this to this, we're going from this way to this way, and then notice that they alternate. All right, so let's label the high and low pressure system. So we've already done this, but we're going to do it again. So once again, I always imagine the equator because I know the equator is extremely hot. It is hot, which means that it is going to have a low pressure system here. Okay, which means that this has to be high, and then they alternate low and then high. And then going on the southern part, we've got low, high, low, high. And then there we go. And so if you look at it, it goes high, low, high, low. They alternate, okay? But I always base mine off of the equator being hot, and I know that hot things have low pressure systems because it's very low in density. All right, so what else affects wind energy other than convection? Wind energy is affected by two main other factors other than the major ones of high to low pressure systems. One is that it actually moves faster and consistently as you get higher in altitude, so that's why it's windier at the top of a mountain versus at the bottom. And then the other one is that it can gather energy when unimpeded. So across the Great Plains, you will have a lot more wind energy because it's been able to accumulate across it without being run into buildings or trees and things like that. So imagine all of these air particles running across an open plain versus running into all of these different objects that'll slow these air particles down. There are some local winds. So those were global winds that we were talking about with the easterlies and the doldrums and things like that. But what we need to know now is that there's also local winds. Okay, and local winds are affected by the local features such as a sea or an ocean, mountains, things like that. Okay, so the four ones that you are going to have to know is sea breeze, land breeze, mountain breeze, and valley breeze. And once again, it is very important to note that you will always go from high to low pressure. All right, so looking at a sea breeze. So notice that it's called a sea breeze, which means where did it come from? It came from the sea. That's why we name it as a sea breeze. A land breeze will come from the land. Okay, so it will be moving from the land out to the sea. For land breeze, it will be going from the sea to the land if it is a sea breeze. So looking at this, why this occurs, if you notice, we've got our warm area right here for the sea breeze, which means that it has a low pressure, where the water above the water is cool, so this would have a high pressure. So notice that once again, whoop, you're going to go from high to low. Okay, and then if you look at it this way on the land breeze, which is at night, you have your high where it's cool, and you have your low pressure where it's warm. So once again, it's going to go from high to low. What you should notice though is that the sun is able to heat up land a lot faster than it is water. That's why water doesn't change its temperature as often. Okay, even if it's like -30 outside, it has to be negative for a long time in order for that water to cool down to a lower temperature. Land, on the other hand, has an ability to heat up really fast, but it also has an ability to cool down really fast. Water, on the other hand, takes a long time to heat up. That's why sometimes in August it's still cold to go on Lake Michigan, but at the same time it doesn't freeze over compared to how cold the land is. So land warms up and cools down a lot faster than water. And that's why you don't notice the land will have a bigger temperature change from night to day compared to water. All right, then there's also the other ones, which is a valley breeze and a mountain breeze. Okay, a mountain breeze is where the wind comes from the mountain. Valley breeze is where it comes from the valley. So what does that mean if I were to try to label the highs and lows? Remember, it always goes from high to low. So this would be high, this would be low. Therefore, I would know, because I see the air going this way, therefore I know that this is hotter comparatively than this, which is cooler because it's got that high pressure system. All right, so now let's try to label the high and lows. So as I've talked about before, when you were talking about high, that means that it is cold. When you're talking about low pressure, it is going to be warm. So this will be your high pressure and your low. And then what type of wind is it? Well, where is it coming from? It goes from high to low. So therefore it is coming from the sea. So this would be considered a sea breeze. So how do we monitor wind? Well, there's 4 different variances of when we're trying to gather or collect this wind energy, we need to take into consideration. First off is the wind direction, which is where the wind comes from. Okay. The second is wind velocity, so how fast is it going? The third is wind shear or turbulence. So is there a lot of change of the wind direction and turbulence in this area? If it is, then that's not going to be as good to gather this wind energy. And then also the power of the wind, okay, which we're really not going to worry too much about these last 2, wind shear, turbulence, and power of the wind. But all of these, when they're trying to build these wind turbines and things like that, they have to take into consideration. All right, you all are going to have to be able to monitor or understand this monitoring of wind, which I believe you guys have already learned in the past. But in this case, the upper left represents your temperature, the bottom represents your dew point, and the top right represents your barometric pressure. For this class, because this just deals with weather, these things kind of really deal with weather more than they deal with the wind, we are not going to have to worry about them. What I want you to worry about is this little tail, okay, and then these guys right here. Okay, so the tail will tell you the wind direction. Remember, you will always have the wind direction. You will always have it going from where it comes from. So this would be a southeast wind, okay? And then what is the speed? All you have to do is match up these little tail guys with your key. Okay, so it's not like you have to really have these memorized, but for this key, you've got 2 big dashes, which represents you have 20, and then you have a half a dash, which represents that it's 25. So this is at 25 knots, and it's coming from the southeast. That's why the tail it's where the tail is kind of pointing at, that's the direction of which the wind is coming from. So actually the direction we would feel it, if we would feel it coming at us from the southeast towards the northwest. All right, hopefully you have an understanding of the basics of wind and have a great day.